Okay, so if we want to add vectors algebraically, then what we need to do is we need to break our vectors into their components. And this is where a coordinate system will come in handy. So for any coordinate system, we can basically break our vectors down based on the fact that with the coordinate system, they create essentially a right-angled triangle. So here's our right angle. We'll call this angle some angle theta for our vector A. Now this right angle triangle has, obviously like any triangle, three sides. And the hypotenuse is the length of the vector A. Okay, the adjacent side, if this point here is, we'll call it XA and YA. Then we know that this adjacent side is XA long. And we know that this opposite side is YA long. So we have this beautiful right-angled triangle, and we can use our trig identities. So we know that cosine of theta is the opposite over the adjacent. So we can figure out what this side length is. This is XA using that identity, and we'll say that it's the length of A, which is our hypotenuse, multiplied by the cosine of the angle theta. And then we can do the exact same thing for YA, and we see that YA equals the length of A, which is the hypotenuse, multiplied by the sine of the angle theta. Okay. Now, if we wanted to add two vectors, what we could do is just like we did before, we could do our tip-to-tail, our graphical method. So our tip-to-tail method where I grab B and I slide its tail to the tip of A, and then that will build some resultant vector that we were calling R before. And I'll just do it as a black vector right here. So there's our R vector. And I'll call that R. And we had before that R, the vector R, this is vector addition, remember, is A, the vector A, plus the vector B. And we said that that was the same as having the vector B plus the vector A. Okay, so how do I do that algebraically? Well, if I break my, just like I did with A, so my A vector here, I broke it into its x components. I figured out what its x components were based on the right angle triangle, and its y components based on the right angle triangle. I can do the exact same thing for B, because remember, I can slide my vector B, I can slide any vector I like, anywhere in the coordinate system that I like. Okay, I can slide it right to start at the origin if I wish. And I can do the exact same thing that I did for A to find what these values are for the x and y components of the vector B. So I can find what this length is here. And we'll call that, if this point is xb, yb, and I can find this length here. So we can see that this length here is yb, and this length here is xb. And we'll call this angle here phi, just so we don't confuse it with theta. And again, this is a right angle triangle, so I can do the exact same thing I did before, where xb is just going to be the length of b, that's our hypotenuse, times the cosine of the angle, which is phi in this case. And the yb is just the length of b again, the hypotenuse of my right angle triangle, times the sine of the angle, which again is phi. Okay, fair enough? Okay, well, if I drag all of that and to get my resultant vector, if I group that all, and I just grab it and tip to tail, move this up, and get my resultant vector. Okay, so what am I doing? Well, essentially, what's happening is I'm going to, for the resultant vector here, for this guy, I basically am going to find the y and x components of that thing. So you can imagine we could do the same thing that we just did for those two vectors for a and b. I could find this y and this x component of this right-angled triangle that makes up my vector r. I'll grab this guy and put him over here so remember that's r. Okay, and this would be essentially, we'll call this side y r, and this side x r. Okay, and this angle here, we will call it alpha, just so we don't mess up with theta and phi. So what are y r and x r? Well, if you look at the picture over here that I've drawn, I know it's a little bit messy, but we'll see if we can figure it out here. If I add this length here, ya, to this length here, yb, what I should get is yr. Okay, and if I add this length here, xa, and I'll add this length here, xb, okay, which is moving in the opposite direction, so it should kind of be like a negative. What I'll get is this length here, xr. Okay, so if I grab all this and group it together and put it back, you might be able to see what I'm talking about there. So I'm going to grab it and I'm going to put it back. Right about there-ish. So we saw that ya plus yb gave me yr, and that xa plus xb gave me xr. Okay? So in general, the x components of r so in general, the x components of r, my resultant vector, are just going to be the x components of a plus the x components of b. And my y components of r are just going to be the y components of a. Okay. The y components of a plus the y components of b. And we've shown that we have a method using right-angled triangles to find out if we know the angle and the magnitude of our vector, we can find out what these values are. Right? We saw that the x components we'd use this color, and the y components were this color. My board's freaking out. Sorry.